Determine the bounded area highlighted in red. Oh, between two functions here. Okay, let's start off with columns. So we pick some point here, and we use some random point. We can pick it down here, and that's going to be the value of x. Okay, and we want to see how big is that little area there? Okay, so let's call it the height of this thing. We'll just call it height, h for now. Okay, that's the height of it. And the width of this thing is dx. That's how wide it is. So the area of that little column is dA, which is equal to height times dx. Great. Okay, let's integrate this thing. So we're going to integrate 1 dA and integrate this thing dx with respect to x. So the integral of 1 dA is equal to a, and now is equal to, now we have to fill in some stuff in here. So we have the integral, we're going to put everything in terms of x because that's what our integral is set up as. It's set up as dx. So all the limits have to be in terms of x. Well, limits are easy because in the x direction it's from 0 to 1. Okay, that's pretty easy. So 0 to 1 in the x direction. But now h has to be a function of x. Okay, well, what is h? So I need to figure out, so if I put in x value, I can get this height from this function, y equals x here. I can get that height right there. Okay, that's just equal to y, right? Or in this case, y is equal to x. So it's just equal to x, but I'm just going to leave it as y there for now. Okay, we'll call it y1. And then this height here, I can get that one too, right there. That one was called, that was going to be y2, right? That's the distance. So if I given a value x, I put an x value in there, it'll give me y2, which is measured from the from y equals 0, the x-axis up. So it's measured y2. So the difference between those is going to be h. Okay, so h is going to be equal to, it's going to be y1 minus y2. Right? That's going to be the difference, right? Because the first one is a bit bigger one minus the smaller one will give me that difference. And I want them in terms of x, because we have to put it in terms of x because that's our integral. So we have to put them in terms of x. So y1 is equal to x minus y2 is equal to x squared. And there it is. Okay, so it's going to be x minus x squared dx. And now we are all ready to solve this integral. So let's integrate that thing. It's going to be 1/2 x squared minus, oops, that's x squared. It looks like almost x subscript 2. That's not right. So that's x squared. So now it's going to be 1/3 x cubed, bracket closed, 0 to 1. Okay. So this is going to be equal to 1/2, put in the first value, so 1 squared minus 1/3, 1 cubed, minus, well, this is all going to be 0, because we 1/2 0 squared minus 1/3, 0 cubed. So it's just going to be equal to 1/2 minus 1/3. What's that going to be? That's 3 over 6. 3 over 6 minus 2 over 6. So it's going to be equal to 1/6. So the area is equal to 1 over 6. In decimal form, 0.16 repeating.